All right, well, we're going to go ahead and get started. Thank you guys for coming. Pretty good audience for a lunchtime crowd. You guys all still look awake too, so another excellent starting point. So we're going to try to keep this interesting. Kriti is going to be speaking with me. I'm Katrina Pickett. I'm with the product management group with the HPE networking for Juniper routing. So,
Kriti Kompella. My LinkedIn says thinker, talker, doer, pick two. Right now I'm picking the talker part, but I do actually have a title.
He is underselling himself. If you don't know Kriti, he invented the internet with Al Gore. Just kidding, they're both overselling that. But he is one of the founders of a lot of elements of Juniper and the internet.
I don't know who she is. Go ahead.
All right, so forward-looking statements, agenda, boring stuff. All right, so let's talk a little bit more about scary things. So how many of you guys monitor or run networks? All right, you are in the right room. How many of you guys have ever dealt with an outage? All right, so outages suck. And there are thousands and thousands of them all the time. Every year, people are experiencing outages. And what this doesn't really cover is all the almost outages, where you get that spinning circle, but it's still technically connected. And these problems, you only have a few seconds to respond before you start getting the complaints, before the customers start seeing it, before your networks start getting affected. And they cost hundreds of billions of dollars. We've got studies at the bottom that when you get the slides online, you can go look at the details. But outages are expensive, whether your point of sale went down, or there was an issue with Heathrow, where the border control could not let people in or out of the airport for hours because of a network outage. So these are the sorts of things that you do not want to be on the receiving end when your boss calls you up and says, how come Heathrow can't get anyone out of the airport? So the nice thing is that some of these outages are really easy to find. Like Godzilla came, he walked through a bridge. Oh, I think we have a fiber cut. Some of the outages are a little bit more difficult to find. Like we have a misconfiguration on one router in a closet in Timbuktu that we haven't looked at in 10 years. So it can be difficult to figure out what's going on. And so now we're going to kind of walk through a specific outage and kind of give you guys all some PTSD flashbacks of what you encountered in your past.
And this is a real outage.
Yes. You may have some ideas on what it was. You can also find it on Google. You guys all experienced its impact because it was in Europe originally. All right, so they had a network. Everything's good. Everything's dandy. This network experienced a DDoS attack. This wasn't strange at all for them. They had 1,700 DDoS attacks a day. It was pretty normal. So they had really good DDoS protection in place. They had mitigation plans in place. So as soon as the attack started, the mitigation kicked off. What they did not know was there was a misconfiguration in their DDoS mitigation plan. And it wasn't causing any problems unless more things happened. So the problem was, it would say, whenever there's a DDoS attack and whenever the mitigation happens, send all of the traffic to anyone who asks for the traffic that's trying to mitigate it. So if all of your routers are in mitigation mode, no problem at all. So everything's going along, mitigation's nice. Oh, 30 minutes later, completely unrelated, a small power outage affects one router in their whole network. Okay, that happens. The DDoS attack ends an hour and a half later per schedule to their normal process. The mitigation plan goes off. Oh, but wait a minute. That one router was offline. It did not get the command to stop doing DDoS mitigation. So it's still mitigating, but it's the only one now. And so all of the traffic is going to this one router. So now we're starting to see some issues. Starts off minor at first, some login issues, a couple people complaining. You can see some red starting to show up on the map. Problem's getting a little bit worse, though. That one router is getting really overloaded, and everywhere it's sending the traffic is getting overloaded. So now we're starting to see a lot of regional congestion. And at this point, we're over 3 hours from the original problem starting. The Impact has only been for about an hour, so not too much of an issue. But now your boss calls you. You're at your kid's football game, and he's like, hey, you need to get to the office. We're experiencing an outage. We have an escalation. I need you to start the war room. It's time to start taking care of this. I'm going to need a status report every 15 minutes. All right, fine. You go to the office. You're working on it. All of Europe's down. You're starting to get phone calls about the point of sale all going out. But now it's hit the whole globe because everyone in the world is sending it to that one router. So now they're really starting to freak out. Now it's not your boss wanting the call. Now it's the CEO calling you every 15 minutes. Is it fixed yet? Is it fixed yet? So they're troubleshooting like crazy. They're looking for the problem. But it's kind of a hard one to find. It was over 7 hours from when they started troubleshooting it to they were able to find the root cause. That's 7 hours of phone calls that you do not want to be on. So at that point, they figured out what's going on. They've got a plan. They put all the routers into mitigation mode. The load spreads out. Things start to settle down. They take that one router offline so they can actually fix it and get everything back up. And their network's better, and they can go home and sleep and catch up on life that they've been ignoring. So we're at 1945. The problem started at 12:55. That's a long time to be in a panic mode. So the question then is, this sucks. We've all been here. How many of you guys saw something that you've dealt with before on this slide? Yeah, it's like, oh, that was me. Other thing that's funny, side topic, I've noticed that sometimes you don't necessarily want to fix the outage. You want to make sure that you can prove to your boss that it was the other team's fault. But you need data for that too. So outages are really bad, and they happen all the time. This is another outage that happened to a tier 1 service provider. They had 2 vendors in their network. 2-vendor network, pretty normal. Everyone does that. So they did a software upgrade on vendor A. Everything looked good. Vendor A was happy. Suddenly, vendor B goes down. Obviously, it's vendor B's problem. So they call vendor B up, and they're like, oh my gosh, you have an outage. They talk to vendor B for 2 days. They're not getting any responses. It's because vendor B sucks, obviously. Finally, vendor B is like, no, no, no. We figured it out. The problem is vendor A. You call vendor A. They're like, no, no, no. The problem's vendor B. And you deal with that for 2 or 3 days. Finally, this outage, what they figured out, it was vendor A, kind of. The configuration file that they pushed down with the upgrade changed a few things. And suddenly, they were sending a prefix flood to vendor B that vendor B was not configured to protect against. So that caused a huge outage that affected about 1/3 of their network, all because of a software upgrade. So can you tell us how we can fix this, Creedy?
Yeah. So let's start by looking at what is happening in the WAN, because the WAN was a nice, boring place, and stuff would happen, but we thought we knew the WAN. But what is happening is people are saying this AI stuff, it's not just marketing. There's actual real use case here, and there's some really good stuff happening. So for example, in healthcare, you can see some really real improvements. So sepsis is down, sepsis mortality is down, radiology is much, much faster, waiting times are down dramatically. If you look at financial services, they're able to do a lot more today using an AI backend to help them out. And then if you look at manufacturing, they're really improving their downtimes. They're having huge productivity gains. So this is all great, right? Well, it's good news, bad news, because all of this requires the network. The AI, the backend that they're looking at, is not with them. So they're going to go over the network to try to achieve this. And so the network is, in the end, going to make or break the value of this AI. So the good news part of it is, and we'll come to that later, the same AI that is doing so well that you have to now provide a network that will support it well, that AI can also help the network. But we'll get to that in a second. So here we are with the traditional trifecta of what is it that we look at when we look at network performance: latency, congestion, and packet loss. OK, Well, how does this affect AI in particular, not just your regular apps? Well, if you have training going on, a 1% packet loss can really put your training back a long way. So you might even have to restart it. So that's a lot of time, power, and investment that has been thrown away because you had some packet loss. If you look at what senior IT leaders are saying, they don't believe that their networks are ready to take on AI loads, generative AI loads. And then in the middle, you see this thing with the financial fraud. You have a very small window in which you can actually detect and report a fraudulent credit card charge or something. So these are all really critical. And if you can't support these guys, if your network can't give them the low latency, the fact that all your packets are getting through, if all that is not working, these AI operations are not going to be successful. So a lot of organizations are saying, we're not ready, and that's almost 60%. The good news is, this is changing the WAN. It's changing it in two ways. The architecture of how you present these solutions is changing. So today, everyone says, I'm going to go basically to a centralized data center that is going to have all of my AI knowledge. And so that's the current model that's preferred. But people are saying, no, 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 you need to distribute this out. You need to make things a little bit different. So by doing that, you are changing the architecture of your network, and you're bringing things closer. You're moving your AI, especially your inference engines, around. So that's all good in the sense that it brings things closer and all, but that's also a change in your network. But more than that, you have to have a new approach to how you not just build your network, but how you operate your network. So we call this AI native routing. So if you look at what you have today, if you look at just your orchestration system, you have these 4 phases that we like to think of: plan, orchestrate, assure, and optimize. So you plan what you want to do, you orchestrate it, then you see, is it doing what it's supposed to do? And then if it's not working perfectly, you optimize it. That's all good. We've been doing this for a while. But now we are putting a thread of AI through all of this. That means every time you're looking at plan or orchestrate or assure or optimize, we're bringing AI to help this and make this work better. And this is not just theory. We're going to show you some demos that show how this actually helps. So the whole thing that the 2 things that you need to think here is, other people using AI, you guys as network operators are going to make their AI successful or not. Then you turn the lens on yourself and say, how do I make this happen? Because as Katrina just pointed out, these networks are getting more complex. There are more interactions that you didn't expect. How am I going to manage this and get this higher level of functionality that my customers are looking for so their AI works? So we'll show you some of this via some demos.
All right, so if we go back to the conversation we were having earlier with the black hole on the traffic, let's take a look at how we could have solved that in maybe a minute instead of 7 hours. So this is our tool, Routing Director. So here we can see a network in Italy. It doesn't have very many nodes. It's mostly pretty good, but you can see there's a little bit of red going off in Milan. So let's take a look at what we have. We're just going to look at one of the healthy nodes really quick. So we have active testing built into the devices. We're able to do testing without disconnecting and doing a test set. If you want to learn more about this, you can go by our booth. We have people there who can talk to you about our active testing. Here I can see I have 0 packet loss. This device is behaving quite nicely. Everything's good. All of this information is feeding our AI, because the first step to making AI useful is giving it data. So now that we know that healthy nodes are healthy, let's take a look at something that's not healthy. So I've zoomed in here on this section, and we can see that there's a little bit of yellow on one side. And if you have Superman vision, you can see that there's 80% congestion going one direction and 0% going the other way. So that's kind of concerning. Let's take a look. So typically what most operators would do at this point, you would probably have agents set up, integration with your trouble ticket system, and you aren't even using our tool right now. You got an email from our tool that said, hey, you need to log on, there's a problem happening, or hey, webhook notification to Slack channel, you have an alarm, you need to go take a look. But if you were looking at the tool, you could come here and you can see a health dashboard. We're going to look at the troubleshooting dashboard, actually, because we want to figure out what's going on here. So we're going to troubleshoot the bad node, and let's see what it's detected. So if we look down here at routing, I can see that I have a black hole. So it found the black hole. So what it's doing, if we take a look at that a little bit more, we actually have a telemetry interface, the Junos Resiliency Interface, JRI. So this interface is helping take a look at a couple different sensors on the device and looking at the potential ways of a black hole. We're also looking at some other sensors on the device with all of our collection. And from all of this, we can see here's some issues that we're having. So I can see the source IP and destination IP of a couple exceptions. So that's kind of useful, especially since I got an email telling me that this was here to begin with. All right, here's the screen I want to talk about. This is probably my favorite screen in the entire feature. So when you're looking at issues with AI, as you guys have all experienced with your own work with ChatGPT and all of those other LLMs you play with in your free time, sometimes it lies, sometimes it makes a lot of guesswork. It has difficulty being 100% certain, so there's a lot of variables on how it ranks things. So this is us exposing the ranking a little bit. So for example, if you were working in the medical field and you had a patient who had died from blood loss, and you were trying to figure out why they died. And they have a small little cut on their arm, and they're having a little bit of blood loss there, and their leg was amputated, and blood is gushing out there. Both things are relevant. They both relate to blood coming out of the patient. But in the one case, this is more critical, so it's more likely to be your root cause of death. So that's why you want to have the relevance and the criticality. So in your networking issue, you would see the same thing. So now we'll see the rest of this video. So once it's detected the issue, the next thing you're going to want to do is try to remediate it. And this is kind of where things get a little bit iffy. Self-driving cars are awesome. How many of you guys used a self-driving car to get to Spain? Or no, nobody? Okay, that's kind of the point. We're not ready for our cars to drive ourselves, and as much as we like to talk about it, we're not really ready for our networks to drive ourselves either. We're still at the step where we're building trust in the system. We want to know that it's going to do what we want it to do before we'll let it do it by itself. So what we have built in right now is a lot of checkpoints, a lot of points where a user can come in and say, yeah, that looks like exactly what I would do. So when I see this issue, if it was working, it would tell me, okay, I can go ahead and do the command that you're suggesting. You think I should turn this device off? I'll go ahead and turn it off. So as we're getting to the next step, and we're trying to solve more, that's where we're getting into the self-driving. And Kriti's going to talk to us about that.
So are you guys familiar with the term agentic AI? I mean, fundamentally, it means I'm giving agency to the AI, which is at which point you duck and run, right, if you were me. So we're going to show you some examples of agentic AI. And we'll start with self-driving cars, although, you know, as Katrina said, some of us are a little bit wary of going there. But the nice thing is they've defined these 5 stages where you have a completely manual car. Maybe it has some sensors and stuff. And then you say, oh, I'll be able to tell you more about what's going on around you. And then I'll be able to give you suggestions to the step where you're assisted. So maybe it keeps the lane for you, or maybe it keeps the speed for you, or you actually have a little more fancy stuff, the, what do you call it, the cruise control, adaptive cruise control. So it says I'll keep the speed at 110 kilometers, or you guys probably do 150 kilometers. But if there's someone in front of you, I'll slow down. So that's nice, but it's still not completely self-driving. in order to get to that self-driving, there's a step jump, and you need this agentic AI. You need to say, I trust the car to do the right thing. So we're taking a very similar approach when it comes to agentic AI in other operations. So in this case, we're talking about self-driving networks. And so we're looking at how I can allow the AI to do things. So Katrina gave you a nice example of trying to figure out what's happening, but we want to go beyond that. So
we should test them. They've been learning about agentic AI all week. We should see who knows, did their homework.
Yes. So let me start. Here are some examples, some use cases that could be or may not be agentic AI. And you guys, a few of you said, you know what is agentic AI. So raise your hand if you think network expansion is an application of agentic AI. Okay, we got a couple.
All right, I'm going to win. They're going to get mine right.
Yeah.
All right, proactive repairs. So you're going to find some complex issues and fix them and verify them. Okay. Just to make sure we're on the same page, all of these might take AI, but is it agentic AI?
Yeah, yes. On-the-job training, is that a use case for agentic AI? Couple, yeah. Okay.
So what about troubleshooting? Like just finding root causes and stuff? Not fixing them, just finding them? Okay.
Vendor swaps, where you're swapping out your network, you know, you have one vendor, you want to bring in a new vendor. Would that be something that agentic AI can help you with?
They'll be bringing in HPE Juniper networking, right?
Right, yeah, yeah. Whatever else you're taking out doesn't matter, but you're just bringing in HPE.
We would be happy to help you take it out.
Yes.
So X-domain analysis. So you're looking across a couple different domains. All right, so who's right?
So here's the actual answers. And the thing that you had to look at, I mean, you guys, I think, were looking at the right things and getting a lot of the pieces right. And a lot of you were just shy, so you're just not responding. But having said that, the important thing that you need to look at is for agentic AI, and I'm not going to go through the full definition. Multi-agent is important. Doing some planning and reasoning about what you're looking at is important. Tool use is important, and reflection, being able to analyze what you've done in the past and bring that to your next thing. But the biggest thing, which kind of is not mentioned here, is you got to do something. So when you're just doing analysis or you're giving recommendations, that's not agentic AI. I mean, there's a lot of AI that goes into that. But if you really want to get in and change things, then that's when you need agentic AI. So let's look at what's possible with agentic AI. And I'm going to start by an example where you're just doing the recommendation. So if you refer back to the self-driving car, the timeline, stage 4, where the car says, I'll do a little bit of stuff, I'll tell you what you should be doing, but you should be driving, you should hands on the wheel. Whereas stage 5 is hands off the wheel. So let's say we want to do this network expansion. And so in this case, you want to bring up a new LSP between 2 nodes. And you want to, before you bring up the LSP, make sure that there's not something going on in the network, make sure that the routers are healthy, there's no demos going on. So you put together you go to Claude or whatever your favorite agent is and say, and I don't think you can read it there. I can barely read it here. I want to create a new tunnel to support AI training and inferencing and blah, 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 and I want you to do these steps before, right? What it's going to do is it's going to go do the analysis, and it's going to do multi-agent stuff. So it's going to go to multiple places to do things, right? So you can see here, that was kind of just pausing the demo. It's going to go to Insights, it's going to go to Active Assurance, it's going to go to the LSP manager and say, what is happening? Can I put in this new LSP? okay, everything does look good. So in the end, it's going to say, here are the steps. The last bit of this is, here are the steps to create a new tunnel. Great, do it. No, 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 you didn't ask me to do it. You asked me to tell you what the steps are. And this is a very nice way to get into it, because then you can say, is the AI doing the right thing? Is the AI actually working correctly? Is it giving me the right steps? And if it is, then you say, I will do it. You do this a few times, and you say, wow, this AI is working well, so maybe this time I will go all the way. So in this case, again, you're trying to set up a new LSP, and yeah. So you're trying to set up an LSP between the two routers at the bottom, at the ends. And then you say, I want you to set up the LSP, but I want you to do the whole thing now. Now, what I should have told you is that the previous thing is, what I just showed you in the previous demo, is things we have today in Routing Director. This is work that we have planning, and it will come out at some point, but exactly when, we will let you know.
Next year.
Next year, yeah. Well, it's the end of this year. So what's happening here is the LLM is going to actually set up the LSP. So you can see the yellow diagonal lines. That's the new LSP. But to know whether it did it right, you're going to take a link off. So the diagonal link between the center of the top center router and the bottom right router has been declared to be down. And so now the LSP will reestablish on the bottom. So you can see it's going across the bottom of the US. So the agentic AI was given instructions saying, create an LSP, make sure of certain things, and if everything looks good, go make the LSP. It did it, and then you said, well, let me see how well you did it. Let me break something. And said, OK, I can reestablish the LSP along a different path. This is not rocket science. This is something that we will have shortly. And this is something that if you have the right information in your systems and you have the right APIs, you can do this. And so hopefully next time we meet, we'll be able to demo this for you.
We just did demo it right there.
We did, but it's a little bit,
Yeah,
next time it'll be completely on its own.
That's the key thing, though, what he said. This isn't rocket science. Connecting an LLM to something is really easy. Everyone can do that. You can find YouTube videos how to do that. The part that's cool is the domain knowledge and the data that's collected and how that gets leveraged by the LLM. So you have to have more than just, I connected an API and everything's done.
One other piece I'd say is that Routing Director is a suite of automation tools. And so when you want multi-agent LLMs, they actually will reside within the suite. Whereas in other cases, you might have to call out to different things and it gets more complicated. I think we have a system that is much more amenable to multi-agent agentic AI.
Now, because it is so cool to talk about agentic AI, and everyone on LinkedIn has probably mentioned it so far this year, you're going to hear every vendor and every company you've ever heard of talking about how they have agentic AI. And I would ask you guys, don't just let them get away with that. Challenge them on what they're doing with it and how their domain knowledge works, because the LLM part was the easy part. So looking at another example, now we're going to take agentic AI and we're going to use it to do some closed loop remediation. So here we're back at that troubleshooting screen we looked at earlier. So I'm going to look at my WAN health. Looks like I'm having some issues with my interfaces. That's not what anyone wants to see in a graph. So I can see I have a lot of link flaps. So now I'm going to dive into these link flaps a little bit more. Looks like it's affecting pretty much every single router in my network, which that's cool. OK. So let's ask Claude, which is a generic LLM you can find online. So we've connected it in the back end to our domain knowledge and our data. And so now Claude is running a bunch of tests. Remember those active test agents, all of our telemetry sensors? It's going through and it's collecting that data and testing to see what the problem might be. So Claude's like, yeah, OK, I think I found the problem. I think you have some scripts running. Would you like me to check for that? So yeah, absolutely, please. So now we're doing that assisted self-driving. So I'm checking its work as I go and I'm deciding. It still hasn't done anything yet, but it's checked everything. It looks okay. Still running tests. Multiple agents, as Kriti was saying a second ago. So it found the problem. It says, I'm having some statistics here. This is your issue. Would you like me to clear it? So another checkpoint. Is this what you want me to do? Do you agree? Yeah. But I want you to do just one router because I don't want you to take down the whole network. So just do one first and we'll see how it goes. So it's running the action it recommended on that one router. Looks like everything's coming up. And so now it's agentic. Now it's taking action. It looked at multiple agents to accomplish it. And this is how you could troubleshoot your network in a self-driving way. So that's a lot easier and a better way to go to the next step. So hopefully, with all this agentic AI and all this AI ML going into your system, that can help you avoid and troubleshoot things faster and make your networks whole more often.
Yeah. So before we jump into this last piece, any questions from anyone? Any parts of this that you didn't believe, you thought we just made up? Any reactions of any kind? The troublemakers will be sent out of the room.
That's how you get them to not ask questions. You should say, anyone who asks a question gets a free iPad.
Yeah.
Kriti's iPad, to be specific.
OK. So it is true that what you saw was a recorded demo, but the demo was actually done. But if you want to see the demo live, go to our booth. We have several demos working there. And this is a journey. And as Katrina said, we believe we have all the right pieces, and we are putting them together in the right way so that it can actually get to where you want to be with the safeguards. Again, like Katrina said, first you can just say, tell me how to do this. And literally, we were doing that yesterday, debugging the problem at the demo booth. How do I do this? And then the next step is, can you do this, but do just one router at a time? But the next time, after you do this 10, 20 times and say, wow, it's got it right every time, you might be ready to just do it on its own. So that's the journey we are on. So we've got a lot of the pieces where you have the agents, you have the multi-agent interaction. The agentic piece where we say you can now let the network or the AI do the changes, we're giving that to you with safeguards over the coming year. So you can see where we are today by going to the booth. If you're not sure where to start, if you want to understand this whole thing about self-driving networks, there's a URL, there's a QR code here that you can go to. Or you can Google me from 10 years ago. I talked about this. I had no idea how to do it, but I did say, this is
It'd be cool
possible.
if we could.
Yeah. If you're new to WAN routing,
Our booth.
again, don't talk about it, don't read books. Go to the NOC. There's the Network Operations Center in the networking area. And we have routers, we have security, we have everything connected. There are diagrams that show how this is all connected so that from your laptop or from your cell phone through the Wi-Fi access point to the router, through security, out to the internet. And you can see how all that works. So it's a nice way of seeing this in real life. And if you've got questions about AI, go to the AI zone, and you can find out what's happening. Because if you blink, there's a new thing that's already happened. So it's always nice to catch up.
And if you were really interested about that slide Kriti showed earlier about how the networks are changing to address AI, we do have a session about that later this afternoon. I think it's at 4 o'clock, where we'll have 2 of our VPs talking about the impact that's having on networks. We've surveyed, I think, 300 different enterprises and service providers on how their networks are changing and what they are seeing in their traffic patterns. So that's all pretty exciting.
Yeah, yeah.
Since we have a little extra time, one thing I want to ask about, Kriti, all this agentic AI is cool, the safeguards are cool, but the next step, it would be really cool if instead of trying things out on one router and seeing if it works, I could deploy it into a digital twin and see how it works.
So how many of you caught my digital twin Airheads talk yesterday? I know none of you did because I had 2 people. So the whole thing, thanks for the plug though. Network digital twin is this idea that you can take your actual network, clone it, put it in the cloud somewhere, and then do things with it. And one of the things you can do with it is to say, let me see how my AI would work. How would it do things in that network? Because what we're saying today is, let it do in my real network, but let it stop at the point where it says, this is what I would do if I were in your place. Well, you could say, no, do the whole thing, but do it in the twin. If you completely break it, I'll just throw it away and create a new twin. So there are a couple of things about network digital twin that really works well with AI. One is to gather more information about your network. So one of the things that you do in your network is you build it so there are fewer errors and the errors are mitigated. In a network digital twin, you clone your network, then you can create situations where more errors will happen so that you can train the AI, because AI lives, thrives on data. And maybe you're not getting the right data in your network because you built it well, which is good. But then when it does happen, you don't know what to do. So you can go to the twin and manufacture errors, manufacture situations that you wouldn't normally get so that you know the AI can deal with it. So that's one side of it, getting data for your machine learning. And the other side of it is what Katrina was saying. You can create that twin and then let your AI run on it and then say, whoa, it's doing really well, or wait, I need to fine tune that. I need to tweak the AI so that it responds better. So, I mean, the network digital twin idea is something that allows you to get much more bold about what you do in the network, rather than say, I need to do this, so I'll do it, but nothing more, because you know, we tend to be very conservative in networks. So the digital twin allows you to be more experimental, more, try new things.
So you can imagine like the misconfiguration scenario. You say, go ahead and configure my network. And instead of doing that, first it sends a silent command off to the digital twin. And then it does exhaustive failure analysis. What if this happens? What if this happens? And then it sends the command back. Nope, nope, that's a terrible idea. Warn them. And then it says, oh, are you really sure that's going to take down all of North America? And you have a chance to react before you take down your network and before you have your black hole.
Yeah.
So, all right, well, thank you guys very much. If you do have any more,
one question.
We have a microphone right behind you.
Thank you. Just a question, because I think in a real scenario we will face the situation where we have multi-vendor environment. How do you address this?
So multi-vendor is absolutely critical in the WAN space, like I was showing that earlier. In some of the other domains, you can be a little bit more single vendor. We have a couple different things built in. Our routing protocols are already multi-vendor. We're doing testing at ENTAC next year, so we are always working with multi-vendor. What we really want to do, it can be a little bit of a black hole. Like keeping up with our own devices and our own releases is hard. Working with 20 other vendors, like when we call Cisco on the phone, they don't take our calls. So they won't give us their router, so we can't. So what we typically do is we focus on standards. We focus on the protocols and we work with those. And then we can, like, the routing protocols are cross-vendor. So we can pull the routing things and then we can run across that. So we have ways of dealing with multi-vendor. We are going to deal with our own stuff better because we can actually test with it more often. But
and one more piece to that. Katrina got it right, that we'll work with standards. And so getting telemetry from routers is now becoming very standardized. So you can use netconf, you can use openconfig. Pushing things to routers is also pretty standardized. So getting and pushing things is nice. The thing that you don't know is, how is this router built up? How is the line card connected to the other line card? What does the fabric look like? Those are things within the box. And so if I want to do root cause analysis, why am I getting this black hole? Sometimes I need more detailed information about the router that I won't get from just standards or from regular books. So I get a manual, it won't give me that detail.
Yeah, that's
So,
what would be a little weak.
there are pieces we can do, and all the pieces that we can do, we are doing, and the pieces that we'll have to learn by experience.
Now, one thing we at HPE Juniper do to try to address that is we're very open about a lot of our information. We put a lot of our Junos information online. You can find a lot of our telemetry sensors. Any vendor who is open like that is better suited for working with these AI protocols because the LLM crawls that information and it gets that, and now it can work with it. We've seen studies where Junos is better and easier to respond with LLMs than other OSs simply because of how open we are as policy.
Did that answer your question?
See, you know, the point is that to use all these AI automation in the network and so on seems to lead to the fact that we have to move to mono-vendor solution that is complicated in the field at the end. So to benefit completely of the feature, we will face the same debate about multi-vendor, not multi-vendor, which decision you have to take in order to improve that. So
there's a guy in 2000 from Global Crossing, I forget his name. He gave a presentation when everyone else was talking about, you know, building multi-vendor networks is what you need to do. He gave a presentation saying, I've built multi-vendor networks, and when I did that, I have to test everything 3 times because I have 3 vendors, and then I have to test it again because I have to test the cross product of things between the vendors. So he made the argument that running multi-vendor networks is much more difficult. But the flip side of it is you don't want to put all your eggs in one basket. So we have to live with multi-vendor networks. C'est la vie.
That being said, ours are the best, so why do you want multi-vendor?
Yeah, I mean.
But, all right, any other questions? All right, well, thank you guys. We'll see you around. See you at the booth. Oh, yeah. Make sure you do your survey, and you can learn more stuff.
Thank you.
All right. Thank you, guys.